Hi, welcome to the video. We're gonna go through implicit differentiation in this video. First we're gonna go through the explanation and just a few examples. This video shouldn't take as long as the differentiation video. So when to apply or how to identify when you're gonna apply explicit differentiation. Explicit differentiation is applied when you have an equation. So typical equation is if one side of an equation equals the other side of an equation, and it's in this type of form, then you will most likely have to apply implicit differentiation. So take for example this equation, y equals square root of x cubed plus 1. Here we have one side of the equation equaling the other side of the equation, and in this case you can see y will be the same as saying fx equals x cubed plus 1, and you can apply normal differentiation rules to get your differential of fx. If you don't know your differentiation rules by now, I suggest you check the previous video I uploaded about differentiation and their rules. So as you can see here, one thing I'd like to state is that y is clearly a function of x in terms of an equation. So if you have an equation, you can see that y and x depend on each other. And if you make y the subject of the formula, then y is a function of x, and that's why we can call it f of x in this case and find the differential. Let's look at y equals, let's say, x sine x. This again has a typical form like this equation over here. So y is still a function of x. It is still the subject of the formula, and there's no other variables. And you can find the differential using the product rule and also knowing the differential of a sine function. You can get that differential. I won't go through that now. I'm just explaining how implicit differentiation will be applied and why it gets applied. So let's take a more complicated equation like x squared plus y squared equals 25. As you can see here, y is not the subject of the formula. It might seem that you can just treat y squared as its own thing, but you cannot, because it is not just a function. It's not fx equals something like we did in the previous video. This is an equation where one side of a formula equals the other side of the formula. In a case like this, a good thing to do is make y the subject of the formula, and if you do, you realize that y y is a function of x, therefore can be seen as f of x again. And that is because it's in the form of an equation and not just a function equals a certain value. So after making y the function of the formula, that's when you can get the derivative of y. Apply the rules that we learned in the previous video. But let's say now you had an equation such as x cubed plus y cubed equals 6xy. In a case like this, you cannot make y and y alone as the subject of the formula. That's because y here is also dependent on y there. So you would struggle to get y alone as the subject of the formula. So this is where implicit differentiation comes in. Now, implicit differentiation is applied in this way. If you have an equation, again, where one side of a formula, where one side of the formula equals the other side of the formula, then you can apply a differential on both sides. So d dx of the left side of the formula equals d dx of the right side of the formula. So let's go back to this equation here. Let's rewrite the equation. X, hope you can still see. Let me just check that it's still visible. Cool. So we have x cubed plus y cubed equals 6xy. So like we said, we're gonna derive one side of the formula. It should equal to the derivative of the right side of the formula. Let's get into it. Here we can apply the sum rule. So this is d dx x cubed plus d dx y cubed equals, here we can remove the constant, so 6 times d dx xy. Let's get into this. The derivative of x cubed is simply 3x squared. The derivative of y cubed, remember that y is a function of x, so we have to treat it like a function of x, not just a constant. So here we have to apply chain rule because now we have function of x cubed. So 3, which is the derivative of y cubed, in this case 3y squared multiplied by the derivative of the inner function being y in this case, so d dx of y. That all equals to 6 times, here we have a product, two multiples of each other of the function. So x times the derivative of the first function, is how product rule is applied. The derivative of the first function multiplied by the derivative of the second function, which is y in this case, plus the second function multiplied by the derivative of the first function. That's how product rule is applied. And can get right into it. We have 3x squared. We have 3y squared. And we can leave derivative of the derivative of the function y as dy dx. On the right hand side, we have 6x dy dx plus 6y, derivative of x in this case is just simply 1, so times 1. Now we're trying to make dy dx the subject of the formula. That's because, remember, we're trying to find the derivative of x, and since y is fx, the derivative of y equals the derivative of fx. Therefore, dy dx equals the derivative of fx. We are looking for dy dx. So we make dy dx the subject of the formula. Let's do that now. Get into it. I'm going to put these two terms, since they contain dy dx, on the left side of the formula, and the other terms we'll leave on the right side of the formula. So 3y squared dy dx minus 6y dy dx equals 6y minus 3x squared. So that minus that equals this minus that. Let's factor out dy dx. On the left hand side, we're left with 3y squared minus 6x. And here we can leave this as is. So to get dy dx on its own, we just divide by 3y squared minus 6x on both sides, and we're left with 6y minus 3x squared over 3y squared minus 6x. We can remove 3 from the numerator and denominator, and we have 3 times 2y minus x squared over 3 times y squared minus 2x. Now final answer is just, because these two cancel out, our final answer is 2y minus, oh, guess you're not seeing this. Our final answer is 2y minus x squared over y squared minus 2x. In case this didn't show in the video, what we did first is we made, let's get here, we made the function the subject of the equation dy dx, and from there factored out 3 from the numerator and denominator, cancelled out 3, and we got our final answer. And that's how you apply implicit differentiation to get your answer. I hope that helped. Bye.